Welcome to another edition of Screencast. This is your host, Ms. Dietrich, and we're going to explore how does changing the dimensions of a figure affect the area. All right, in this particular it's asking the dimensions of a 7 centimeter by 2 centimeter rectangle are multiplied by 3. How is the area affected? All right, let's just help ourselves understand by drawing it. If this is 7 here, and this is 2 centimeters, and we multiply these by 3. By the way, the area of this would be 14 square centimeters. 7 times 2 is 14. If we figure out what would happen if we triple the dimension, 7 times 3 is 21. 2 times 3 is 6. Now let's figure out what the area of the bigger shape would be by multiplying 21 times 6. Here we get 6, and here we get 12. So the new area is 126. Now they want to know, what do I have to do to the 14 to get 126? To figure that out, you'd have to do 126 divided by 14, and you would end up getting 9 for that. So you're multiplying it by 9. 14 times 9 is 126. Now I want to point something out, and that's, what if we change this to being an 8 and this to being a 3? How would it affect our answer? Or would it affect it? So let's kind of explore that for a moment. Change the dimensions, which means none of this applies here. And we're going to see if that times 9 thing still comes up if we triple the dimension. All right, so let's pretend that this is 8 and this is now 3. To triple the length of this, 8 times 3 would be 24 for the bigger one. If we triple this, 3 times 3 would be 9. The area of the smaller figure would be 24. The area of the larger figure, we'd have to multiply 24 times 9. And here we get the 36. 2 times 9 is 18. 21 with the 3 more. The larger area is 216 square centimeters. Now, is 24 times 9 216? And this is the evidence that it is, right? So that means it doesn't matter what the dimensions are here. I can change it to, a 9 and a 4. It can be anything. As long as you're tripling the dimensions, that means your area is always going to be 9 times bigger.